Bismillahir Rahmanir Rahim. All right, so this is lecture number 1.2 of International A-Level Edexcel P3. In the previous lecture, we talked about the basic concepts, the multiplication and division of fractions. Okay, we did exercise 1A practice, and then we started with the concept of addition and subtraction of fractions. Okay, the addition and subtraction of fractions, and then we solved a few examples. Okay. And now we have some questions from exercise 1B, particularly the exam style questions. So first of all, we have this question, exercise 1B, question number 4. The question is saying that express 6x plus 1 divided by x square plus 2x minus 15 minus 4 upon x minus 3 as a single fraction in its simplest form. All right. So first thing first, we are going to factorize this x square plus 2x minus 15. This is a quadratic expression. So, 1 times 15. So in place of 15, we can write 5 times 3 as well. And this sign tells us that we have to subtract the factors. And this sign tells us that we need to get positive 2 in between. So x square plus 5x minus 3x minus 15. So taking x common multiplied by x plus 5, taking minus 3 as common multiplied by x plus 5. Okay, so x plus 5 multiplied by x minus 3. Alternatively, what you can do is you can put this quadratic expression in your calculator equation function mode, okay, and solve the polynomial with a degree of 2, and you will get two roots. One root would be x is equals to minus 5, and other root would be x is equals to 3. And through these two roots, you can write the factorized form like this, x plus 5 multiplied by x minus 3. Okay, so after this very first thing, you can write this step as well. Okay, but my usual practice is to do the factorization manually. Okay, so 6x plus 1 divided by x plus 5 multiplied by x minus 3 and then subtract 4 upon x minus 3. Now, in the last lecture, I told you a quick way to, identify the LCM, to identify the lowest common multiple. Okay, you don't need to always show the steps of finding the LCM. Okay, so the technique which I told you was that the factor which is exactly repeating will come only once and the other factor will be multiplied. जो फैक्टर आपका exactly repeat हो रहा है वो एक मर्तबा आ जाएगा और बाकी जो फैक्टर है वो मल्टीप्लाई करा के लिख देंगे. Okay, so even you, if you find the LCM by the same method which I told you in the last class, in the initial questions, in the initial examples, you will get the same LCM over here. Okay, so if you want to find the LCM of x plus 5 multiplied by x minus 3 and x minus 3. Okay, so let's say we start from x minus 3. So x minus 3 multiplied by x plus 5 will give you this complete expression, and x minus 3 into 1 will give you x minus 3 itself, and then x plus 5 multiplied by 1, and here you have 1 as it is underneath 1. So in the end you are left with 1 comma 1. So whatever the product of these two terms is, that is basically the LCM. So x minus 3 multiplied by x plus 5 or x plus 5 multiplied by x minus 3, same thing. All right, so my point is that you don't need to show the LCM always in this particular way. Okay, you can just use a simple technique which I have mentioned. All right, so here is the thing. So LCM would be x plus 5 multiplied by x minus 3. And now you need to ask yourself by what term you multiply x plus 5 multiplied by x minus 3 such that you get this complete expression. Obviously, you need to multiply it with 1. So the numerator will also be multiplied by 1. So 6x plus 1 as it is. And then we have the subtraction sign. Okay, and you ask yourself by what term you multiply x minus 3 or what expression you multiply x minus 3 such that you get x plus 5 multiplied by x minus 3. Obviously, you need to multiply it with x plus 5. So here the numerator will also be multiplied by x plus 5. Okay, and the subtraction sign is already mentioned over here. So 4 multiplied by x plus 5. after this subtraction sign. And now what you need to do, you need to expand the numerator. Okay, so 6x plus 1 minus 4x minus 20 divided by x plus 5 multiplied by x minus 3. So therefore 2x and then 1 minus 20 is basically minus 19. So 2x minus 19 divided by x plus 5 multiplied by x minus 3. This is supposed to be your answer. Okay, we have obtained a fraction in a form after which we cannot do any simplification. We cannot cancel out any common factors further. So this is supposed to be your answer. All right, so this was exercise 1B, question number 4. So now let's move on. So up next we have question number 5. Okay, part A and part C are your homeworks. Okay, I'll just do this part B over here and then I'm going to move on. So 4 upon 3x minus 2 upon x minus 2 plus 1 upon 2x plus 1. Okay, here we have three fractions. Okay, so first of all, as we can see that, here we have three distinct factors, meaning three distinct expressions in which you can see that there is no common factor in between these three factors. Okay, कुछ भी repeat नहीं हो रहा. All right. So there is no factor which is being exactly repeated. So obviously, the LCM would be the product of these three expressions. So 3x into x minus 2 into 2x plus 1, this will be the LCM. And now you need to ask yourself by what term you multiply 3x such that you get this complete expression 3x multiplied by x minus 2 multiplied by 2x plus 1. Obviously, you need to multiply it with x minus 2 multiplied by 2x plus 1. So the numerator 4 will also be multiplied by x minus 2 multiplied by 2x plus 1. And then we have the subtraction sign. And you need to ask yourself by what expression you multiply x minus 2 such that you get this complete denominator over here. Obviously, you need to multiply it with 3x and 2x plus 1. So this numerator 2 will also be multiplied by 3x and 2x plus 1. And same goes for the last one, that you need to ask yourself by what expression you need to multiply 2x plus 1 such that you get this complete denominator over here. You need to multiply it with 3x into x minus 2. So the numerator 1 will also be multiplied by 3x into x minus 2. And now you are going to simply expand the numerator. So 4 is already common outside. First I expanded x minus 2 multiplied by 2x plus 1. So 2x square plus x minus 4, x minus 2. Okay, and then we have minus 2 as common outside, and 3x multiplied by 2x plus 1 is 6x square plus 3x, and then 1 is multiplied by 3x multiplied by x minus 2, so 3x square minus 6x. And this is completely divided by 3x multiplied by x minus 2 multiplied by 2x plus 1. All right, I hope you have copied this much working. So now in the next step, I can say that, this 2x square plus x minus 4x minus 2 is basically 2x square minus 3x minus 2. But this expression will be multiplied by 4 as well. So after multiplying it with 4, I will get 8x square minus 12x minus 8. And then minus 2 into 6x square, and then minus 2 into 3x. Okay, minus 2 into 3x, and then 3x square minus 6x. And now I'm going to simplify the numerator. So minus x square minus 24x minus 8 divided by 3x multiplied by x minus 2 multiplied by 2x plus 1. This is supposed to be your answer. Okay. After this, you cannot simplify anything because, if you take this minus sign as common in the numerator, you are left with x square plus 24x plus 8. And if you put x square plus 24 x plus 8 in your calculator equation function, or even if you put this complete numerator in your calculator equation function, even if you put this complete expression in the numerator in your calculator function, you are going to see that, the roots are coming in surd form. So obviously, there would be no common factor over here. In this whole fraction, there will be no common factor. ऊपर नीचे कोई भी कॉमन फैक्टर एग्जिस्ट नहीं करेगा, सो यू जस्ट लीव योर आंसर एज इट इज. Okay, so minus x square minus 24x minus 8 divided by 3x multiplied by x minus 2 multiplied by 2x plus 1. This is supposed to be your answer. Okay, so this was basically the question number 5, part B. Part A and part C are your homework. All right, so now let's move on. So up next, we have another question. This is exercise 1B, question number 6, and other exam style question. It says that express 4 multiplied by 2x minus 1 divided by 36x square minus 1 plus 7 upon 6x minus 1 as a single fraction in its simplest form. So first of all, I'm going to factorize this 36x square minus 1. Okay, now as you can see that I can write this as a difference of the squares. Okay, so in place of 36x square, I can simply write 6x whole squared. Okay, so this becomes 6x whole squared minus 1 squared. And then you factorize it, so you get 6x plus 1 multiplied by 6x minus 1. So now I can rewrite the question in this form. I can rewrite these two fractions in this form. 4 multiplied by 2x minus 1 upon 6x plus 1 multiplied by 6x minus 1 plus 7 upon 6x minus 1. Agreed with this? And now I need to take the LCM, and a quick way to find the LCM. Whatever factor is being exactly repeated will come only once, and then the remaining factor will be multiplied. Okay, so 6x plus 1 multiplied by 6x minus 1 would be the LCM over here. Okay, so you need to ask yourself by what term you multiply 6x plus 1 into 6x minus 1 such that you get this denominator over here. Obviously, you need to multiply it with 1. So this numerator will also be multiplied by 1. So 4 multiplied by 2x minus 1 as it is. Okay, and then you need to ask yourself by what term you multiply 6x minus 1 such that you get this complete denominator over here. Okay, so obviously you need to multiply it with 6x plus 1. So this numerator 7 will also be multiplied by 6x plus 1. So here I've mentioned 7 multiplied by 6x plus 1. And now I'm going to expand the numerator. So 8x minus 4 plus 42x plus 7 divided by 6x plus 1 multiplied by 6x minus 1. Okay, and now I'm going to simplify the numerator. So 8x plus 42x is 50x and 7 minus 4 is positive 3. So therefore 50x plus 3 divided by 6x plus 1 multiplied by 6x minus 1. This is supposed to be your answer. All right, so this was question number 6 of exercise 1B. So now let's move on. All right, so up next, first of all, we have a P2 book example, because the next question of exercise 1B, which is question number 7, it basically, uses the long division method, which you are studying since P2. Okay, so before discussing that question of exercise 1B, first of all, I need to recall a few concepts of P2. And for that purpose, I have discussed this P2 book example over here. Okay, ताकि वो steps आपको याद आ जाए. Okay, so that you can recall those steps of doing the long division method, which is going to be frequently used in this chapter of P3. Okay, so here we have a basic example from P2. Find the remainder when x cube minus 20x plus 3 is divided by x minus 4 using part A is saying algebraic division, meaning the long division method, and part B is saying the remainder theorem. Okay, so first thing first, what we need to do, we need to divide this cubic polynomial by x minus 4. Okay, so as you are already aware of the fact that when you are using the long division method, you need to write a polynomial in a strict sequence. Okay, so this is a cubic polynomial, so x cube, and then conceptually there should be a term in x square, but the term in x square is not over here. You have x cube minus 20x plus 3. So according to a strict sequence of the polynomial, you are going to write this polynomial like this, that x cube plus 0x square minus 20x plus 3. Okay, this strict sequence of writing the polynomial when doing the long division method, we are doing this since P2. And anyways, I have also shared the basic lectures of P2 in the P3 WhatsApp group as well. Okay, those who want to more recall their concepts of P2 polynomials can see those lectures. Okay, three lectures I have shared basically, lecture number 1.2, 1.3, and 1.4 from P2. Okay, so that's basically the thing. But however, here I'm also discussing the P2 examples step by step to make things easier for you. All right. So this polynomial x cube plus 0x square minus 20x plus 3. Okay. This is divided by x minus 4. So first of all, you need to ask yourself by what term you multiply x such that you get x cube. x को ऐसी कौन सी टर्म से मल्टीप्लाई कराएं कि एग्जैक्टली हमारे पास x क्यूब आ जाए। ये सारी बातें हम P2 में भी करा करते थे। Okay, all of these steps and all of this conversation which I am telling you, we used to do in P2 as well. Okay, so I've also shared a reel of my Instagram account, in the WhatsApp group in which I have discussed another example and explained the detailed steps of doing the long division method. Okay, however, that lecture is in Urdu, but here I am also discussing the same steps in English Urdu mix as well. Majority of the portion of my lecture, inshallah, this time will be in English. But whatever I'm saying in Urdu in these recorded lectures, which you are listening right now, I will translate those words in English as well. All right. So you need to ask yourself by what term you should multiply x such that you get x cube. Obviously, you need to multiply it with x square. x को आप जब x स्क्वायर से मल्टीप्लाई कराएंगे तो जाके x क्यूब आएगा, तो जाके x क्यूब के अंडरनीथ एग्जैक्टली x क्यूब लिख देंगे. And then you multiply this x square with minus 4 such that you get minus 4x square. Now, as you can see that this x cube is not being eliminated because our first purpose, our first intention is to eliminate this cubic term. तो बज़ाहिरन अभी एलिमिनेशन नहीं हो रही है. As you can see that elimination is not happening over here. But if you multiply this expression with a minus sign, so the sign of both of these terms is going to change. बज़ाहिरन अभी एलिमिनेशन नहीं हो रही, लेकिन अगर नीचे वाली एक्सप्रेशन को माइनस की साइन से मल्टीप्लाई कराएं तो दोनों टर्म्स की साइन जो है वो चेंज हो जाएंगी. ऑल राइट, सो एक्स क्यूब माइनस एक्स क्यूब गॉट कैंसल्ड आउट, eliminated, dead, इंतकाल. And 0x square plus 4x square, which will give you 4x square. And then you are going to write minus 20x as it is. And in the same way, you are going to continue the comparison. As you can see that you have two terms exactly over here, and here you have two terms exactly. So you are going to continue the same comparison until you get the remainder. Okay, so what you need to do, you need to ask yourself by what term you multiply x such that you get 4x square. Obviously, you need to multiply x with 4x. x को ऐसी कौन सी टर्म से मल्टीप्लाई कराऊं सच दैट मेरे पास 4x स्क्वायर आ जाए. 4x के साथ मल्टीप्लाई कराओ. All right, so that you get 4x square underneath 4x square. You get exactly 4x square underneath 4x square, and then you multiply this 4x with minus 4, so you get minus 16x. अब बज़ाहिरन तो एलिमिनेशन नहीं हो रही, और वो हो भी नहीं रही होती भाई. हमारी इंटेंशन ये होती है कि इस 4x स्क्वायर के अंडरनीथ एग्जैक्टली 4x स्क्वायर आ जाए. As you can see that elimination is not happening over here. Okay, but we need to multiply this expression with a minus sign such that this gets eliminated, because our purpose, our intention was to obtain 4x square exactly underneath 4x square, so that we can multiply this expression with a minus sign and then the elimination can actually happen. All right. So 4x square minus 4x square got cancelled out, eliminated. And the sign of minus 16x, this becomes positive. So this becomes positive 16x. Now in minus 20x, 16x is being added. So this will give you minus 4x. And then 3 will be carried as it is over here. And now you are going to continue the comparison in the same way. All right. And now you need to ask yourself by what term you multiply x such that you get minus 4x. You multiply it with minus 4 such that minus 4x comes exactly underneath minus 4x. And then this minus 4 is multiplied by minus 4. This will give you positive 16. So as you can see that the elimination is not happening right now. But if you multiply this expression with a minus sign, so the sign of each and every term will get changed. Sign of these two terms will get changed. And now you can say that, this 16 becomes minus 16. And this minus 4x becomes positive 4x. So minus 4x plus 4x got eliminated. And 3 minus 16, which is minus 13 is basically the remainder. And here you are going to stop. Okay, this is purely a P2 question. P2 book example, a very fundamental, a very basic example which I've brought over here before actually discussing question number 7 of exercise 1B. All right. In P3, you are going to continue the same concepts of P2 which you studied last session. All right. So, most of the students have studied P2 from me, but there are few students who have not studied P2 from me. So to treat them all equally, okay, obviously, my usual practice is to recall the basic concepts as well. All right, it's my responsibility, it's my duty, it's an obligation upon me. Okay, so I'm just fulfilling my obligation. Okay, so the thing is that by algebraic division, we found the remainder which is minus 13. And now we are going to find the same remainder by the remainder theorem in part B. Okay, so this was, part A. So now let's come on to part B. So in part B, we need to find the remainder using the remainder theorem. So first thing first, here I have mentioned the remainder theorem concept. When polynomial px is divided by x minus a, so the remainder is pa, because x minus a is equated with 0, so x is equals to a. This x is equals to a becomes the input of the polynomial. So whatever the output is, that is basically the remainder. This concept you are studying since P2. This is the remainder theorem actually. Okay. However, if the polynomial is divided by x minus a, so x minus a is equal to 0, so x is equals to a. And when you put input of the polynomial, x is equals to a, and if the output is equal to 0, this is called factor theorem. Okay, this is also the concept of P2. Okay, when input of the polynomial is a, so output is equal to 0, this is the factor theorem. This means that x minus a is a factor and x is equals to a is a root. Okay, when the remainder becomes 0, so that is basically factor theorem. All right. So here I have mentioned the concept just for the sake of formality, and here I've solved this part B. Okay, so when this polynomial is divided by x minus 4, so x minus 4 is equal to 0, so therefore x is equals to 4 will be kept input of the polynomial. So let's say the polynomial is fx or gx or hx or px, whatever you want to say it. Okay, so let's say fx polynomial is x cube minus 20x plus 3. So x is equals to 4 will become input of the polynomial. So whatever the output of the polynomial would be, that will be the remainder. Okay, so we just need to find the value of f4. So just substitute x is equals to 4 inside the polynomial. So 4 cube minus 20 into 4 plus 3, meaning 64 minus 80 plus 3. Therefore, remainder is minus 13. Okay, so in this way, we have attempted this, a very basic example from P2 book. Okay, so I hope you have copied this much page. So now let's move on. So now let's come on to exercise 1B, question number 7. Okay, so the question is saying that gx is equals to x plus 6 upon x plus 2 plus 36 upon x square minus 2x minus 8, where x can take any real values and x is not equal to minus 2 and x is not equal to 4. In part A, we need to show gx in this form. Okay, and as you can see that when x is equals to minus 2 would become input of this gx function. So this x plus 2 will become 0 and gx is going to be undefined. And in the same way, if you put x is equals to 4 as the input of the gx function, so x minus 4 will become 0, which will again make the denominator 0 and make this function gx undefined. Okay. So therefore, x is not equal to minus 2 and x is not equal to 4. Here is the reason to write this domain over here. Okay. Anyways, first we are going to show part A, and then in part B, we are going to use algebraic long division. So first of all, I'm going to factorize this x square minus 2x minus 8. Okay, so 2 times 4 is 8. And after subtraction, we need to get minus 2 in between. So x square plus 2x minus 4x minus 8. So taking x common multiplied by x plus 2, taking minus 4 as common multiplied by x plus 2. Therefore, x plus 2 multiplied by x minus 4 is the fully factorized form. All right. So now what we are going to do, we are going to rewrite this gx function like this: x plus 6 upon x plus 2 plus 36 upon x plus 2 multiplied by x minus 4. Now, as you can see that, you know, below x we don't have anything. Okay, जब x के नीचे कुछ भी नहीं है तो x के नीचे 1 तो आ जाएगा. So, as you know that in place of x, I can write x over 1 because x is the same thing as saying x over 1. So, I basically mentioned this x as a fraction as well. X means x over 1. So, I'm conceptually finding the LCM of these three terms, you can say. All right. So, as you can see that x plus 2 is being exactly repeated. So, it will just come once. X plus 2 exactly repeat हो रहा है तो सिर्फ एक मर्तबा आएगा. And then the remaining things will be multiplied. So x minus 4 is also multiplied and 1 is also multiplied. Eventually your LCM will be x plus 2 multiplied by x minus 4. So now you need to ask yourself by what expression you multiply this 1 such that you get x plus 2 multiplied by x minus 4. Obviously multiply it with x plus 2 multiplied by x minus 4. So this numerator x will also be multiplied with x plus 2 multiplied by x minus 4. So here I've mentioned the complete thing. Then you need to ask yourself by what expression you need to multiply x plus 2 such that you get this complete denominator over here. You need to multiply it with x minus 4. So the numerator 6 will also be multiplied by x minus 4. So here you go, plus 6 multiplied by x minus 4. And then you need to ask yourself by what term you need to multiply x plus 2 into x minus 4 such that you get this denominator over here. Obviously, you need to multiply it with 1. So this numerator 36 will also be multiplied with 1. So now, as I am already aware of the fact that, you know, this x plus 2 into x minus 4, the expansion was, x square minus 2x minus 8. So I could have just simply avoided this step and I could have mentioned x square minus 2x minus 8. But anyways, I still did the complete expansion. So x is multiplied by x square minus 4x plus 2x minus 8 and then 6x minus 24 and then plus 36. Okay, so x square minus 2x minus 8 will be multiplied by x so that you are going to get x cube minus 2x square minus 8x plus 6x plus 12. Okay, because 36 minus 24 is 12. So therefore you have obtained your answer in the very next step. You are just going to simplify these two terms in x. So therefore, gx is equals to x cube minus 2x square minus 2x plus 12 completely divided by x plus 2 multiplied by x minus 4. All right. So this is supposed to be your answer to part A. So now let's move on to part B. So now coming on to part B on the very next page. Okay. So first of all, I have mentioned this basic identity which you are studying since P2. Okay. This is a basic polynomial relationship, or you can say a basic polynomial identity. That polynomial is identical to quotient multiplied by divisor and then plus remainder. This qx is quotient, this dx is the divisor, and this rx is basically the remainder. Okay, so first of all, I need to explain this thing, that how we are going to use this identity over here. Okay, and then we are going to solve this part B and we are going to get our answer. So first of all, I need to do this adjustment with this basic polynomial identity. Okay, and that adjustment is to basically multiply 1 over dx on both sides, or you can say divide the divisor on both sides. Okay, you can also say that divide dx on both sides. Both statements mean the same thing. So what would be the outcome? That when polynomial is divided by divisor, okay, so this will be identical to qx into dx upon dx plus rx over dx. Okay, so therefore I can say that px over dx is identical to qx plus rx over dx, because the divisor and divisor got cancelled out. Now we are going to use the identity in this way. Now whatever you have obtained in part A, as you can see that gx is equals to x cube minus 2x square minus 2x plus 12 divided by x plus 2 multiplied by x minus 4. Whatever you have obtained in part A, I can say that this is a form of polynomial divided by divisor. This is the form of px over dx. Agreed? A cubic polynomial is being divided by a quadratic polynomial, and the quadratic polynomial is mentioned in a factorized form. Okay, so we are just going to expand x plus 2 multiplied by x minus 4, and we are going to simply divide this cubic polynomial by the quadratic polynomial over here. So using algebraic long division or otherwise, further show that gx is equals to x square minus 4x plus 6 completely divided by x minus 4. All right, so what we are going to do, we are going to divide the polynomial by the divisor, meaning this result which you have obtained in part A, x cube minus 2x square minus 2x plus 12 will be simply divided by x plus 2 multiplied by x minus 4. Okay, so here basically what I did, I'm aware of the fact that the expanded form of x plus 2 into x minus 4 is basically x square minus 2x minus 8. This I already used this fact in part A working as well. Okay, so basically what I'm going to do, I'm going to divide this cubic polynomial by this quadratic polynomial. All right, so you need to ask yourself by what term you multiply x square such that you get x cube. Obviously you need to multiply this x square with x such that x cube will come exactly underneath x cube, and then this x will be multiplied with minus 2x, so you are going to get minus 2x square. Okay, and then this x will be multiplied by minus 8, so that you are going to get minus 8x. Okay, and as you can see that the elimination is not happening, but if you multiply this expression with a minus sign, so the sign of each and every term will get changed, and x cube minus x cube got eliminated, but the term in x square also got eliminated. मकसद ये था कि x क्यूब की टर्म एलिमिनेट हो जाए, लेकिन इत्तफाक से x स्क्वायर की टर्म भी एलिमिनेट हो गई. Our intention was to eliminate this cubic term, but in the procedure, x square term got eliminated as well. Okay, our purpose was not to eliminate x square, but it got eliminated. So no worries, I'm going to write it like this: 0x square, meaning the coefficient of x square is 0, and then minus 2x plus 8x, so this will give you 6x, and then 12 will be carried as it is. So here we have 6x plus 12. Now after this, I have performed very extra steps just for your understanding. If you just completely avoid this, that's perfectly fine, because remainder you have already obtained 6x plus 12. Now how to identify that if it is a remainder? As you know the fact that remainder's degree is always below the divisor's degree. रिमाइंडर की डिग्री हमेशा डिवाइजर की डिग्री से छोटी होती है. Alright, remainder's degree is always less than the divisor's degree. Okay, so as the divisor is a quadratic polynomial, so remainder can be linear expression as well, remainder can be a constant term as well. Okay, so as you have seen that remainder is coming out to be linear, so you are going to stop there. Remainder is coming out to be linear. So once you have identified that the remainder's degree is now less than the divisor's degree, so you are going to say that this is the remainder which we are trying to find out. Okay, because remainder's degree is always below the divisor's degree. So the remainder is now linear. Okay, the remainder cannot be quadratic. Remainder cannot be quadratic. If there was any other term in x square other than 0, I mean x square term got eliminated. Our purpose was not to eliminate x square term, but it got eliminated. So what can we do? But if there was a term in x square existing, so we would have carried the same procedure. Make sense or not? Until we get the remainder. And the other reason to identify that this 6x plus 12 is a remainder, you ask yourself by what term you multiply x square such that you get 6x. So that unknown term would be 6x divided by x square, which means 6 divided by x. Now 6 divided by x is exactly the same thing as saying 6 multiplied by x raised to the power of minus 1. Okay, so if you write 6 multiplied by x raised to the power of minus 1 over here, so this is not according to the definition of the polynomial. Okay, as we know the matter of fact that polynomial is basically a finite expression with positive whole number indices. Okay, the power of each and every term in the polynomial, either it is a positive integer or it can be 0. The power cannot be minus 1. Power cannot be a fraction even. Okay, these things you already know since P2 when we were identifying that which expression is a polynomial and which expression is not a polynomial. So whatever the definition of the polynomial is, that same definition would apply on the quotient as well, divisor as well, and the remainder as well. जो पॉलिनोमियल की अपनी फीचर्स हैं, अपनी ज़ात में जो पॉलिनोमियल की पहचान है, वो कोशेंट की भी पहचान होगी, वो डिवाइजर की भी पहचान होगी, और वो रिमाइंडर की भी पहचान होगी. Okay, so whatever the conditions there are, in order to fulfill that an expression is a polynomial, the same things are going to apply for the quotient individually, divisor individually, and the remainder individually. All right. So here I've just mentioned a very extra step just to give you an understanding. We have dealt with these type of questions in P2 as well. Okay, so when the comparison is starting, when the procedure of comparison is starting and the very first term is not existing, when the procedure is starting and in the very first term the coefficient is 0, so what happens is that you can completely skip this thing. But just for the sake of formality, you are going to ask yourself by what term you multiply x square such that you get 0x square. Obviously, you multiply it with 0. So 0x square comes underneath exactly 0x square. And then this 0 is multiplied by minus 2x. So you are going to write minus 0x. And then this 0 is multiplied by minus 8. So this will become minus 0. And we multiply this expression with a minus sign. And the sign of each and every term gets changed. So obviously 6x plus 12 will be the remainder as it is. So I'm just trying to tell you that even if you avoid these steps over here, I've mentioned this highlighter. Okay, so that's perfectly fine. 6x plus 12 would be the remainder. But just for the sake of formality, just for the sake of understanding, I've mentioned this step. Okay, so always remember this thing. Remainder's degree is always less than the divisor's degree. All right, so that is basically the thing. So now I can say that, I have obtained my identity in this form. Because in part A, we obtained in this form polynomial divided by divisor. And now I'm going to say that I have obtained an equivalent form, quotient plus remainder over divisor. So now gx has become like this. The quotient is just simply x. If I say x plus 0, or if I say simply x, both mean the same thing, right? Agreed. So x plus 6x plus 12 divided by x plus 2 times x minus 4. But we need a specific form, a specific requirement. Okay. So as you know that in the numerator, I can take 6 as common. In the numerator, I can take 6 as common. So x plus 6 multiplied by x plus 2 divided by x plus 2 into x minus 4. So this x plus 2 and x plus 2 got cancelled out, and therefore x plus 6 upon x minus 4. But the requirement is not yet complete. x के नीचे 1 लिख देंगे. We will write 1 below x. Okay. We need to express this as a single fraction in a required form. So LCM will be x minus 4. So 1 multiplied by x minus 4. So the numerator x will also be multiplied by x minus 4 plus x minus 4 into 1 is basically x minus 4. So this numerator 6 will be multiplied by 1. So 6 as it is. So therefore, x square minus 4x plus 6 divided by x minus 4, this is supposed to be your answer. This is the required form of gx in part B, which we need to find, which we need to show actually. So we have shown that gx is equals to x square minus 4x plus 6 divided by x minus 4. Okay, so this is basically one way to do this. We have another way by using the same approach, by using the long division approach, but the approach is a little bit different. So here I'm just going to mention this alternative approach, alternative solution of part B, and then we are going to conclude this lecture, and then we are going to continue, inshallah, in the very next class, in the very next lecture. Only last exercise, which is exercise 1C, it is left, and the concept behind it is improper fractions. So improper fractions concept we are going to start in the very next lecture. Okay, and then we are going to do exercise 1C practice, and then this chapter number 1 will get completed, inshallah, and then we are going to do the topical past papers questions of this chapter, and then we are going to move on to the next chapter, functions and graphs. Okay, so here we have an alternative approach for part B, only for part B. Now, as you are aware of the fact that just focus on these two fractions. In part A, we have obtained gx in this form, and in part B, we need to show gx in this form. Now, as you can see that, x plus 2 is getting eliminated in the denominator. Okay, so this obviously implies the fact that x cube minus 2x square minus 2x plus 12. In place of this cubic polynomial, we can write x plus 2 multiplied by a quadratic polynomial. This makes sense or not? In place of this x cube minus 2x square minus 2x plus 12, what we can do, we can write x plus 2 multiplied by a quadratic polynomial ax square plus bx plus c. That quadratic polynomial is basically unknown to us right now. This makes sense? Okay. So what we are going to do, we are going to identify that unknown polynomial by using the long division. As we know the matter of fact that x plus 2 is getting eliminated. So this definitely implies the fact that x plus 2 is, coming in the numerator as well. And here you can see that x plus 2 is present in the denominator as well. So x plus 2 would be a common factor in this fraction. It would be a common factor in the numerator and the denominator. This makes sense or not? x plus 2 eliminate हो रहा है तो x plus 2 ऊपर नीचे common होगा, isn't it? So what I'm going to do, I'm going to divide this cubic polynomial x cube minus 2x square minus 2x plus 12 with x plus 2. I'm going to divide this cubic polynomial with x plus 2 by x plus 2. Okay, so starting with comparison, by what term you multiply x such that you get x cube? Obviously, x will be multiplied by x square so that you get x cube underneath exactly x cube, and then this x square will be multiplied by 2, so this will give you 2x square. So as we can see that the elimination is not happening, but when this expression is multiplied by a minus sign, so sign of each and every term gets changed. So x cube minus x cube got eliminated, and minus 2x square minus 2x square, which will give you minus 4x square, and minus 2x will be carried forward as it is. And then you ask yourself, by what term you multiply x such that you get minus 4x square? Obviously, you need to multiply x with minus 4x so that you get minus 4x square underneath minus 4x square. And then this minus 4x gets multiplied with 2, so you get minus 8x. और बज़ाहिरन एलिमिनेशन नहीं हो रही और वो हो भी नहीं रही होती. The elimination of this x square term is not happening, but we will multiply this expression with a minus sign so that the term in x square gets eliminated. So this becomes minus 4x square plus 4x square, and this becomes minus 2x plus 8x. This minus 8x becomes positive 8x, so that you are left with 6x, and then 12 is carried forward as it is. Now x will be multiplied by 6 such that you get exactly 6x underneath 6x. Okay, you are obtaining 6x exactly below 6x, and then this 6 is being multiplied with 2 such that you get 12. And then this expression is multiplied with a minus sign. So minus 6x minus 12, the remainder is 0. So polynomial is identical to quotient multiplied by divisor plus remainder. Okay, this identity, this very basic identity you are studying since P2 as well. Okay, I have shared the basic lectures of P2 as well in the PC WhatsApp group. So if anyone wants to revise the polynomial concepts in more detail, with more questions, with more practice, can watch those particular lectures. Okay. So anyways, in the very next class, I'm also going to discuss, why this identity exists. बेसिकली ये P2 का चूंकि बेसिक कॉन्सेप्ट है, तो अभी मैंने उतनी बेसिक बात अभी यहाँ पे डिस्कस नहीं की. वैसे मेजॉरिटी बेसिक बातें मैंने सारी डिस्कस कर ली हैं. However, I have shared the lectures as well. So in the very next class, in the very next lecture of P3, I'm also just going to mention this thing, that why this identity is occurring. All right. Anyways, this, the proof of this identity is also covered in the P2 lectures as well, which I've shared with you. Okay. Because, the thing is that we are not studying P2 right now, actually. We are studying P3. But in order to build the basics of P3, we are using the concepts of P2. Okay. So main focus is P3 content by using the basic concepts of P2. So as much as I can discuss things in a class, I will. So you don't need to be stressed about it. So here we have the basic polynomial identity. Polynomial is identical to quotient multiplied by divisor plus remainder. Okay, so x cube minus 2x square minus 2x plus 12. This is exactly identical to quotient multiplied by divisor, because the remainder is 0. Remainder है ही नहीं ना. Khalas, remainder is 0. So x square minus 4x plus 6 is multiplied with x plus 2. Now this means that I can rewrite my gx function in this form, that in place of this cubic polynomial in the numerator, I can write it as a product of a linear polynomial and a quadratic polynomial. मैंने cubic polynomial को linear multiply by quadratic की form में लिख दिया. All right. So x square minus 4x plus 6 multiplied by x plus 2 divided by x plus 2 multiplied by x minus 4. Okay, so x plus 2 and x plus 2 got cancelled out. X plus 2 and x plus 2 got eliminated. And therefore, congratulations, you have found the required form. Gx is equals to x square minus 4x plus 6 divided by x minus 4. All right. So here we are going to conclude this lecture. This was P3 lecture number 1.2. Okay. And the further things we are going to discuss in the very next class, very next lecture, inshallah. So I hope you understand this much. So if anyone is having any issues with these basic concepts of P2, they can just let me know. Okay. Although I have shared the basic P2 lectures along with basic concepts and practice in the P3 group as well. Okay. For the fifth time, I've mentioned this thing in this recording anyways. So if anyone is having any troubles, they can just let me know. So I'll be able to solve your specific queries, inshallah. Okay, so concluding this lecture, see you in my next lecture. Assalamu alaikum. I hope you have copied this much page. Stop recording.